We will first prove that the distance between Matthew and Jessica is given by this function, that is f of xy equals under the root of x squared plus y squared minus 2xy cos theta, where x represents the distance of Matthew from the point P and y represents the distance of Jessica from point P, and theta is the angle between their paths with point P. So to prove this, I'm going to construct a triangle, that is ABC. Basically, I'm going to use the cosine rule. So let me construct the triangle ABC and mark the vertices as capital A, capital B, and capital C. And this small letter A, this is the side opposite to the vertex A, and I mark this lowercase b, which is the side length opposite to vertex B, and this lowercase c, which is the side length opposite to vertex C. So in any triangle, that is here it is a triangle ABC, we can write down one of the cosine forms, that is a squared equals b squared plus c squared minus of 2bc and then cosine of angle A. So this is one form of the cosine rule. There are two more forms. Here we will use one of the forms of this cosine rule. Now we can apply this cosine rule to our triangle, which is formed over here. Maybe I could just connect this and show this as a triangle, that is the distance between Matthew and Jessica. So clearly this, we have a triangle APB, and in this triangle we can apply the cosine rule. So let me reconstruct the triangle. That is we have this triangle, this point is P, and this is A, and this is B, and this distance is X, this distance is Y, and this angle is theta. So we can write down this AB when we apply the cosine rule. So this AB represents the side length A according to this triangle ABC. So therefore we can write down this AB square, and this equals square of this side, that is AP square plus PB square minus of 2 times of AP times PB, and then cosine of the angle between the side lengths AP and PB, which is the angle is theta. So we put like this. Now we can replace AB by f of xy, because it is the distance between the two persons, Matthew and Jessica, which is represented by f of xy. So therefore this becomes f of xy, and this is quantity square, and this equals AP is the distance from Matthew to point P, which is represented by x squared, and we can replace PB by y, which is the distance from Jessica to the point P, minus of 2 times of AP is replaced as x, and PB is replaced as y, and then we have this cosine of theta. Now we can take a square root on both sides, so that we will get only f of xy on the left side. So I'm taking the square root. When I take the square root of square function, we will get only the function. And this side we have to take the square root. You can put the square root symbol like this. So basically it becomes x squared plus y squared minus of 2xy and then cosine theta. So therefore, we were able to show that the distance between the two persons, Matthew and Jessica, is equal to this expression, which is under the root of x squared plus y squared minus 2xy cos theta. We will now determine the rate at which the distance between Matthew and Jessica is changing based on this given information. That is, basically, we have to determine this df over dt. So first, let me rewrite this as simply as f, and this equals, I'm going to write down this in terms of power form, that is x squared plus y squared minus 2xy cos theta raised to the power of 1 half. Now I'm going to differentiate both sides with respect to time. So this will become df over dt, And we first apply the power rule. So when we apply the power rule, we put the power in front and raise this expression, that is 2xy cos theta, to the power of 1 by 2 minus 1. So 1 by 2 minus 1 is negative half. So we will have negative half here times, we have to apply the chain rule to differentiate this expression inside this power. So we have to put d by dt of the complete expression, that is x squared plus y squared minus 2xy cos theta. Now let's simplify this. So we can rewrite this in terms of positive powers of 1 by 2, and then rewrite that power as power of 1 by 2 as root function. So I'm going to do that over here. That is df over dt. This equals 1 divided by 2 times of x squared plus y squared minus 2xy cos theta. This is under the root times of derivative of this expression. We are going to find the derivative with respect to time. So let's find the derivative of each of the terms inside the bracket with respect to time. So we can put this as d by dt of x squared plus d by dt of y squared minus d by dt of 2xy cos theta. Then I close this bracket. Now this expression will remain as it is, that is 1 over under the root of 2 times of x squared plus y squared minus 2xy cos theta. This remains the same, multiplied with differentiation of x squared with respect to time is, when we apply the power rule, we will get 2x, and also we apply the chain rule, so it will be dx over dt. And similarly, differentiation of y squared applying the power rule, we get 2y, and applying the chain rule, we get dy over dt. And here, this cos theta, because theta is fixed, cos theta is also a constant, and 2 is a constant. So you can just factor out the constant and find the derivative of the remaining expression. That is, we will have 2 times of cos theta times of d by dt of xy. And we know that this to differentiate this, we have to apply the power rule. So we will do it over here. That is d by dt of, I'm sorry, we have to apply the product rule. So when we apply the product rule, we differentiate x, that is dx over dt times of y, plus then we keep the x as it is, multiply with the derivative of y with respect to time. So this is the expression that we get to differentiate xy. I'm going to replace that over here. So I can just remove this and multiply with this expression. So I can write this as y times of dx over dt plus x times of dy over dt. I can just erase this. Now let's continue. So we can see that we have this 2 over here, as well as we have 2 in all the terms. That is, we have 2 here, we have 2 here, as well as we have 2 here, which means we can factor out the 2 out of this bracket, and we can cancel it with this 2. So these 2 gets cancelled. So therefore I can remove these 2's. So these 2 is gone now. Now let me rewrite this. So we have 1 over x squared plus y squared minus 2xy cos theta. This is under the root times of inside the bracket, we have x times of dx over dt plus y times of dy over dt minus of cos theta, and then this expression. that is y dx over dt plus x dy over dt. Now let's substitute the given values into the expression. So we have x equal 11 and y equal 24. So this is we have x equals 11, y equals 24, and we are also given VA equals 5 meter per second. Basically, VA is the velocity along the path which is run by Matthew. So we can rewrite this in a different way as this is dx over dt. So this is given as 5 meter per second. So 5 meter per second, and also VB, which is the velocity of the other person running along his direction, his or her direction, and this is VB equal to 4 meter per second, and this can be written as a dy over dt, and this is given as 4 meter per second. So let's substitute all these given values into this expression. So therefore this becomes 1 over x squared is 11 squared plus y squared is 24 squared minus 2 times of x is 11 and y is 24, and then cos of, we're also given the value of theta, which is pi over 3. So we put cos of pi over 3. This is everything under the square root times of this expression, that is x times of dx over dt. X is 11 and dx over dt is 5 plus y is 24 times of dy over dt, which is 4. So I put 4 here, minus cos of pi over 3. We have a bracket times y dx by dt. Y is 24 and dx over dt is 5 plus x is 11, and then dy over dt is 4. So we close this bracket. We also close this bracket. So it's basically we just have to plug this into the calculator. That is, we have to first simplify this expression. Maybe if we simplify this, we will get 11 square is 121 and 24 square is 576, and then we multiply these numbers. 2 times of 11 times of 24, and this equals 522, and cos pi by 3, the value of cos pi by 3 is half, so I can put this as zero point 0.5, and this should be under the square root, and then we have these numbers. 11 times of 5 is 55. This is 55 plus 24 times of 4 is 96, minus cos pi by 3 is 1 by 2. I write this as zero point 0.5, and then 24 times of 5 is 120. 24 times 5 equals 120 plus 11 times 4 is 44. So now it's easy to calculate. So we can in fact put this into the calculator, and when we do that we get approximately as 3.316 meters per seconds. Since this is the rate of the distance, we write down this unit as meter per second. So this is the rate at which the distance between the Matthew and Jessica is changing.